Hello everyone, this is the Unit 2 review sheet. We're going to go over a lot of topics and we're going to start right now with topic number 1, finding the slope and y-intercept. Find the slope and y-intercept of the linear equation y equals 1 over 3x minus 5. Can't get any easier. Remember, the equation of any line in slope-intercept form is y equals mx plus b. The m is the slope. That is the number that is before the x, and the b is the y-intercept. So this is your m and this is your b, including the sign that is in front of it. 1/3 is the slope. 5 is not the y-intercept. It is -5. So 5 is not the y-intercept. -5. So -1/3 is not your slope. B is out. D is your answer. 1/3 slope. -5 is the y-intercept. Number 2, find the equation of a line that has a slope of 4 and a y-intercept of -2. So remember, y equals mx plus b, the equation of a line in slope-intercept form. We're going to take the m as the 4, the b as the -2. Y equals 4x minus 2. That is it. Number 3, what can you conclude about the graph of a line that is given this equation, y equals -5x? Before I look at the choices, I am just going to go ahead and put down m is -5. And I know that the b is 0 because there is no, it's a direct variation. There is no other y-intercept of like 2 or 1 or anything like that. So this line has a slope of 5. Well, it doesn't have a slope of 5. It has a slope of -5. So that's out. The line has a y-intercept of 0, -5. No, the y-intercept is 0, 0. The line passes through the origin. Yep. The line passes through 0, 0. The y-intercept is 0. The line rises from left to right. No, it's going down from left to right because it has a negative slope. So that is it. It goes down from left to right. Number 4, the slope of this line is x1, y1. Label first, x2, y2. M equals y2 minus y1 over x2 minus x1. Remember, when you have a graph, if you're finding the slope, rise over run works best. But if you have 2 points, 2 coordinates in a table or anything like this, you're just going to use the y2 minus y1 over x2 minus x1. So my y2 I labeled as 9. The minus sign comes from the formula itself. The y1 is 7. Then you have x2, which is 3, minus sign from the formula itself, and then a -3. Remember what we said in class. The 2 negatives, the minus a negative is a positive. Just go ahead and change it right there. You could grab your calculator and just go ahead and figure this out right now, or you could do it by hand. But if you do it on the calculator, the best way is to press that button that I just pressed. That's the fraction button. We have 9 minus 7. It'll take you right to the answer, and then 3 plus 3 is there. So we have m equals 2 over 6, but then it has an arrow down next to it. That is to simplify. Simplify it. It is 1/3. So the m equals 1/3. And that is supposed to be an m. Slope is 1/3. That means it goes up from left to right. And it's not a very, very steep slope at all. All right, so here we go. Find the slope of this line, this graphed line. This is when you're going to use rise over run. So we are going to go put m equals rise over run. Remember, they don't want anything else here. Just the rise over run, the slope. They give you 2 points. So I'm going to use those 2 points no matter what. So I'm going to go ahead and create my triangle. I'm going to go down first, and then I'm going to go all the way over to the right. And then I'm going to count 1, 2, 3, 4. Since I'm going down, that's a negative 4. I'm going to the right here. 1, 2, 3, 4, 5, 6. So my rise is negative 4. My run is 6. If I reduce that, and if you don't know how to reduce, you could bring up your calculator and you could put in from the fraction symbol right there, negative 4 over 6. And if you press enter, it'll give you the negative 4 over 6 again with the arrow down. So you press simp and you enter, and it'll give you that it is negative 2 over 3. And that is it. Which graph shows a function in which the rate of change and the y-intercept are both positive? So we're looking for a positive rate of change and a y-intercept that is above the x-axis, because everything above the x-axis is a positive y-intercept. So do you see this x-axis right here? This right here, down here, this y-intercept, that is below. So we're talking about a negative y-intercept and a negative slope. They want both positive, so that A is out. I'm going to go back to the highlighter and highlight this right here. That's the x-axis. So we are looking at this as the y-intercept. Since the y-intercept is 0, it does not have any sign, so B is out. C, the y-intercept is there, and this is the axis, so you know the y-intercept is positive, and then this line goes up, so that slope is positive as well. C is your answer there, so that's basically it. Number 7, which equation represents the line? Remember, equation equals y equals mx plus b. So all of these are in y equals mx plus b, but I just want to kind of just look at this line. It's going down from left to right. If you don't see that right off the bat, the first thing that you should really look at, all right, yeah, the slope, we need the slope, but the b is the easiest thing. The y-intercept, where it crosses the y-axis, is right here. So if it crosses right there, that is 5. So I have a 5 here, I have a 5 here, I have a 5 here, I have a 5 here. I can't cancel anything out. Since this goes down from left to right, it's going down. The line is going down from left to right. That means it has a negative slope. A negative slope goes down from left to right. The line goes up, it's a positive slope. So let's look now. See, this positive slope, that would go up from left to right. That's out. Here's a negative slope. That goes down. Here's a negative slope. Here's a positive slope. D is out. So it's between B and C. And now we do have to get that slope. So I'm just going to I'm going to pick 2 points. All you need is 2. All right. So we're going to go down 1, 2. So that's negative 2, down 2, and over 1. So the rise over run is negative 2 over 1. The y-intercept is 5. Negative 2 over 1 is negative 2. So the equation of this line is y equals negative 2x plus 5. And negative 2x plus 5 is b. And that is it for that. All right. Remember, this is a pretty steep line, and steep lines, it's going down, so the decline is pretty steep. So it's nothing like a half. A half wouldn't be as steep. It would go across the whole coordinate grid and everything like that. All right, topic 2, graph interpretation. So they love to ask these questions on any kind of test, state exam or anything like that. So for which interval is the function, I'm going to take my highlighter out, which interval of x, by the way, of x, is it decreasing and linear? So let me just go ahead and put down under decreasing, because that's what decreasing means, and line So it has to be a straight line. So the line has to be straight. Okay, so decreasing. So I'm going to go ahead and go up here. That's increasing. So that's out. Right? Then I'm going to take this right here. That is not increasing or decreasing. That's a slope of 0. And then I'm going to take my highlighter and I'm going to go down right there. And so we have right here increasing. So this is decreasing. And it's linear because it's a straight line. And decreasing because it's going down. So now I'm going to draw down a dotted line down to in between 10 and 20 is 15. And it stops here at 40. C is your answer. Between 15 and 40, we have a decreasing and linear function. This is it. That's it. It's pretty easy when you look at it and you understand the what the question is asking. So we went over this in class, this question. Sandy's water dish. Is Sandy's a dog? What's one possible interpretation of the section of graph from 30 to 60 seconds? So I'm going to put that in a highlighter, green, right there. So Sandy started, Sandy is a dog, starts right here, 400 milligrams of water. It stays 400 milligrams of water, then goes down. Sandy's drinking at that point, and then it stays 300 milligrams of water right there, and then goes down. Sandy's drinking at that point. Then it stays 100 milligrams of water, and then Sandy drinks all of the water. All right, so let's go back and see. Between 30 and 60, the water is staying the same there. So let's go and answer this question. What's one possible interpretation of the section of graph between 30 and 60 seconds? Sandy was drinking water between 30 and... No, she wasn't. It stayed the same amount of water, 300 milligrams. Sandy stopped drinking water to investigate a noise. Okay, that's possible. I'm going to circle it. Sandy tipped the bowl of water over, making a mess all over the floor. If Sandy did do that, it would go down to 0 immediately, and it didn't go down to 0 immediately, so that's out. The owner filled up the bowl. The bowl is not being filled up at that point. The bowl is staying the same. It had 300 milligrams of water between here and here, so B is your answer. We're going to cancel out D and everything like that. So the graph of a function is shown below. Describe each section of the graph, linear, nonlinear, increasing, and decreasing. So section N is right here, and I'm going to try to do this in different color highlighters. So section N is right here. What is happening in that section? Is it linear or non? It is linear. And we are going to say it's increasing because it's going up from left to right. Section P, I'm going to take my highlighter now and go in green. And the same thing. Linear. Increasing. Section Q, we're going to do in blue, is linear. And it has a slope of 0. So it's not increasing or decreasing, but that has a slope of 0. Any horizontal line has a slope of 0. Remember, vertical lines have an undefined slope. So if we have one more color in highlighter right here, that section there is R, and that is linear and increasing. And that is that. So a bicycle club went on a 6-hour ride. The graph below shows the relationship between the number of hours, remember time is always on the x-axis, spent on trails and the number of miles traveled. So here we go with this. What happened in the 3 to 4 hour time period? So I'm going to take my pen, and so here's 3 hours right here to 4 hour time period. So at that point, you have to take a look at the side here, what the Y is standing for, like what it says. All right, it says distance in miles. So if there is no distance being covered and time is going by, they probably stop for lunch right about here. So in between 30 and 35, so probably around 32 miles, they stopped and they took a break. They took an hour break. So they probably ate lunch. So B, how many hours did it take the bicycle club to ride 50 miles? So let's see, 50 is right here. So I'm going to go over and draw my dotted line all the way over to the end right here, and then go down. How many hours is that? That is 6 hours. So how many hours did it take the bicycle club to ride 50 miles? 6. So 6 hours. And that is it. Remember, you just kind of just look at, you're just looking at the graph, and you're drawing those dotted lines over from the y-axis to the line itself, and then determining how long it took them. And that's basically it. Right? So that was graph interpretation. Topic number 3, writing and graphing linear functions when not given m and b. Very simple. You have to solve for y equals mx plus b. That is the equation of a line. That's what we've been doing for the last like 2 months. So when you're asked to find the slope in the y-intercept, you must solve for y. So the way you solve for y, you have 3x plus 5y equals 10. Please don't say that the slope is in front of the x, the 3. It's not going to be that. So remember, you have to subtract the 3x from both sides. What you're doing is that you're solving for y. So you have to start to get the y alone, and that's the reason why you're getting the 3x away from the side where the 5y is. Then when you rewrite everything, it's 5y equals. Do yourself a favor. You see this negative 3x? Put it first. And then put the plus 10 second. This way, it's almost like y equals mx plus b right there. But there's one more step to get the y alone. You have to do the opposite of multiplication. You divide by 5. So we're going to cancel out the 5. And we're going to have y equals. And right now, we have negative 3 over 5 right there. You see it? Keep that fraction. Don't change it into a decimal. Keep it. And then remember to bring down the x. You see this 10 divided by 5? That's 2. So it's plus 2. So now you have the slope of the m equals negative 3 over 2. It is a negative slope. It goes down from left to right and crosses at y-intercept as 2. That's it. It's done. You're finished. All right. Remember, solve for y. Find the equation of the line. Remember, equation of the line. Y equals mx plus b. Same thing you're doing over and over again. So you need the two things, though. You need slope and you need the b. When x is 0, the other number is your y-intercept. Okay, let me say it again. When the x is 0, the other number is your y-intercept. So I put it down there. When x value is 0, the y value is the y-intercept. So I'm going to take a highlighter and just highlight this most important point right here. So we have 0, -2. There's your y-intercept. So it's -2. To get the slope, you have to do y2 minus y1 over x2 minus x1. Just a word like to the y's. Like you see these negative, the negative coordinates here. I'm going to just go down to 0. You can pick any two that you want. So I'm going to go down to this 0 and put that as my x1. And this is my y1. And this is my x2. And this is my y2. You could pick the first two. You could pick the second two. You could pick the last two like I did. Whatever you want to do. Whatever's easier for you. All right. So I think it's easier to pick the last two in this case. So my y2 is 28. My y1 is a -2. You notice I have a double negative. I'm going to change that to a positive right away. And then I have 6 minus 0. I could put this into my calculator, or I could just go ahead and do 28 plus 2 in my head. That is 30. 30 over 6, that is 5. M equals 5. So my slope is 5. My y-intercept is -2. My equation of this line is y equals 5x minus 2. And that is my y equals mx plus b right here. Right? Equation of the line. All right. Probably some of the most difficult questions right here. But we're going to go ahead and see if we can figure this out. This takes reading, and you have to know these formulas. It says find the equation in point-slope form. So point-slope form is just the y minus y1 equals m times x minus x1. So I'm going to put it up here. Y minus y1 equals m times x minus x1. And yes, you need to know this for any test or quiz or anything like that. Over here, I'm going to just put x1, y1 and x2, y2. The reason why I'm doing that is because I have to find the slope of the line first. You see this m right here? It's missing. They're not giving you the slope. If they gave you the slope in a point, you just go ahead and put those numbers in, and substitute them in, but they don't give them to you. So we are just going to go ahead and figure out the slope. So this is y2 minus y1 over x2 minus x1. So we're going to put m equals, and we're going to set this up with the minus signs because those are from the formula. There are no negatives here, so it's 8 minus 5, and then 6 minus 5. So my m, which is pretty easy, 5, 6, 7, 8, it's 3 over 1, which is 3. So now we're going to go over that. That's all they wanted me to do right there. So point slope form. So look at number 4. It says use your slope and the coordinate pairs from question 3. We got it. We have it. Use the point slope formula to find the equation of the line in point slope form. So here's the point slope form. And this is basically what they want you to do. And I just wanted to get rid of that and just go like this because it looks nicer and it makes me happy. All right. So if it makes you happy, that's great. Let's go ahead and substitute what we have in. Do you see right here? You see this y minus y1? X1 and y1 is 5 and 5. Nice and easy. See this y? I'm just going to rewrite it. Y minus, from the formula, y1 is 5. So I'm going to use this 5 as my y1. See, y1 is 5. Then I'm going to use this m. You see this m? Equal sign from the formula. And then m is 3. Parenthesis, x minus, and then I'm going to go back and get my x1 is 5. And I'm going to put that in. And you see what I have here? This is the equation of the line in point slope form. You don't have to do anything else. You don't have to do anything else. But for C, going forward, use the point slope form, this, for the equation of the line in slope intercept form. Remember, slope intercept form is our favorite y equals mx plus b. So we're going to rewrite y minus 5 equals 3 times x minus 5. And we are going to solve it for y, because at the end, it's going to be y equals mx plus b. So we're going to have 3 times x and 3 times negative 5. So we have y minus 5 equals 3x minus 15. One more step, and we solve for y plus 5 plus 5. And we have, right now, we're going to move this over, cancel it out, and we're going to go over here, y equals 3x, and then negative 15 plus 5 is negative 10. And that is the equation of the line in slope-intercept form. So I'm going to put it here, 3x minus 10. Y equals 3x minus 10. All right, equation of the line, slope-intercept form. It's done. It's finished. And we're got 100% on that. All right. And let's go on to number 5. Use the linear function 6x plus 2y equals 10 to answer the following questions. All right, so find the slope and y-intercept. Anytime you have to graph, this is a combo graph question and find the slope and y-intercept. You have to find the slope and y-intercept to graph it, because if you don't, you're not going to be able to graph it. So we're going to subtract 6x on both sides. Remember, you have to get y equals mx plus b. This format is what you need. So this cancels, and we are going to go over here and get 2y equals, and remember, bring that negative 6x down first, and then the plus 10. One more step, you divide by 2, and then we're going to put y equals, and we're going to negative 6 divided by, divide right now, negative 6 divided by 2. And if you don't, listen, you could use your calculator. Negative 6 divided by 2, if you don't know it, is negative 3. So that is negative 3. And then don't forget the x coming down. And then you have 10 divided by 2. 10 divided by 2 is 5. So the y equals mx plus b is there. The slope is negative 3. Since you're graphing it, put it in rise over run, and then the y-intercept is 5. So anytime that you are graphing something like this, you're going to want the rise over run. And since you have rise over run, we're going to take that negative 3. Is that going up or down? If it's a negative, it's going to go down. So we're going to put that arrow down to remind us, directional arrows remind us which way to travel when we have that first point. And remember, this 1 is not negative. This 1 is positive. So we're going to go to the right. This is the y-intercept. Please put your first point at 5. First point at 5, then we go down 1, 2, 3, and then to the right 1. 1, 2, 3, down 3, to the right 1. Down 3, 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. And then 1, 2, 3, to the right 1. Since we need points up here, we're going to go up. We're going to do the opposite. Up 3, 1, 2, 3, to the left 1. We cannot go any further. Do you notice how all the points are in one straight line? Right? Because it's the same slope throughout. Remember, when you draw your straight line with the arrows, with the ruler, to make sure that you are putting arrows on each side of the line, because it goes on forever. So we have this, and please put the last thing that you do is put the equation on the line. Remember, this is a negative slope, so yes, it goes down. It crosses at 5. We are done. Graph the function using the slope and the y-intercept. We did. That is the equation y equals negative 3x plus 5. Create an equation that is parallel to that. So y equals negative 3x plus 5 is what we're looking at here. Remember, every time you have parallel lines, they have the same slope, different y-intercept. So I'm just going to make one up. Same slope, negative 3x plus 4. Same slope, different y-intercept. Same slope, different y-intercept would mean that they are parallel lines. So that's it. I put it there in blue. Same slope, different y-intercept will mean that the lines are parallel, and that's it. Our last topic, topic number 4. Oops, it's not our last topic, but we're getting close to the end here. So let's go ahead. This is real world representations of linear functions. So the cost to rent a boat includes an initial fee of $9 plus $6.50 per hour. So that means we are going to take this right here, and we are going to say that that is the slope, the rate. So we're going to put m equals $6.50 per hour. Remember, this is multiple choice, so you're not going to have to make this up and then put it into an equation. You're just going to have to pick the equation that this represents. The initial fee is the y-intercept. So we have that up here. This is the y-intercept, and this is the keyword is per. That's the m. So we have a 650. A slope of 650 and a y-intercept of 9, so it's 650x plus 9. And that is the equation of that line, and it's right here. I didn't even see it. It's 650x plus 9. By the way, this right here is the same thing as 6.50. All right, so it's just really B. All right, and that's about it. Number 3, I don't know how it skips from 2 to 3, 1 to 3, but the graph to the right models the gallon usage of a car based on miles driven. What's the initial amount of gallons of fuel in the tank, and the miles per gallon, that's the slope. So the initial amount is the B, and the miles per gallon based on the graph. Right now, I'm going to go right here and say that there are 15 gallons in the tank to start. So the initial amount is 15. That's good. Initial amount 0? No. Initial amount 7? No. Initial amount 15. So it's between A and D. So I'm just going to pick 2 points. And you see this point right here? That's a good point as well. It's in the corner of the box. It has integer, whole numbers, coordinates. So this is negative gallons in the tank. So -1 and then 25 miles. So 25 miles driven, and you're using a gallon. So that's 25 miles per gallon. That's the reason why it's D. It is not like you're going 50 miles per gallon. You're going 25 miles using a gallon, going 25. Using a gallon, you could just go down the whole thing. Driving 25, and just like this. All right, so that's about it right there, and D is your answer. All right, number 4. Cab company charges a boarding rate of $30. So let me go ahead and highlight the most important information in addition to $10 for every mile. So the boarding rate is your B. The initial cost is the $30. Like, it's before you even get, like, say, like when you get into the cab, before the cabbie goes, the cab driver goes, going to charge you $30. All right. And then $10 in addition every single mile. What's the rate? It's $10 per mile. So I'm going to put that here. The M is 10 over 1. And I'm going to put $10. And I'm going to put mile. And the B is $30. That's my initial rate. Right, so let's go ahead. Now, remember, the X represents the miles. And it's usually time on the bottom, but we're going to put miles. All right, and dollars, money, always goes on the Y-axis. So this is money, and this is miles. When you're labeling, start with 0, and then go 1, 2, 3. Right underneath each line, don't put the numbers inside the center of the boxes. You're not counting boxes, you're counting lines. And we're going to go all the way up to 15, just like that. So now comes the more difficult part, right? The money part. So we're going to start with whatever the cab company charges for just the first charge, the initial rate, the boarding rate is $30. That's exactly what we're going to start with. We're going to start with 30. And then what is the cab company charging this person or whoever, any person, per mile in addition to the 30? Yes, it's $10 per mile for every mile after the $30 is paid. So for the next mile, that would be 40 for the first mile, right? Because you have to pay the boarding rate of 30, and then you have to go up by tens, because that's what the person has to pay. Whatever they start with, you start with. Whatever they pay per mile, you go up on your graph per mile, just like this. So you're counting by tens at this point. After the initial 30 boarding rate, it's $10 per mile. So I'm going up to 160. This is 155. And then the last one is 160. And that is really what you are going to do. You're rising 10 and running 1. And by the way, I didn't put the equation of this down. Since the slope is 10, the rate is 10, the y-intercept is 30, it is 10x plus 30. So let's go ahead and put our first point down. It is not 0, 0. Remember, when the person got into the cab company charges $30 boarding rate. So for 0 miles, $30. It's unfair, but. And then you go 1 mile, you pay 10 extra. So that's 40. Then you're going 10 extra, you're paying 50. You're going another mile, paying another 10. Another mile, another 10, and it goes up like this. Just like this. And we're going to draw a straight line. Always do that with a ruler. And it's coming from, remember, it's 0, 30 as your first point. Remember, put the equation on a line. And also put an arrow at the end. It is y equals 10x plus 30. That is your graph. And that is it. So if they ask you a follow-up question, which I'm going to ask you now, if a person goes 10 miles, how much would they pay? So my follow-up question, if a person, how much will a person, okay, so if you could see that question right there, how much will the cab company charge for a 10-mile trip? So we're going to look at our graph to help us out on this one. So let's go ahead and see if we can get this perfect. And it's not going to be perfect, but it is good enough. All right. So let's go over to 10 miles. Draw a dotted line up from 10. And we're going to go right up 10 miles. 10-mile trip. Hit the line and then go across. How much would that person be charged? It would be charged $130. That is a follow-up question. Now, we don't know if that's going to be on the exam, but if anything, that's how you do it. You could figure out all the way up to a 14-mile trip on the graph. A 15-mile trip would go off the graph, but you could figure it out. And then anything beyond 15 miles, you would have to use the equation and substitute for the amount of miles. Like I say, if they said, how much would a 50-mile trip cost? You would do y equals 10 times 50 plus 30. And then you'd figure out how much that trip is. All right. So Tim is selling tickets to a school sporting event to raise money for his club. He put some extra money in the box before he began. He sells tickets and he records the number of tickets he sold, and it is the data below. So the total amount of money from ticket sales right here, assuming all tickets are the same price, write an equation that represents the situation in table A, part A. So find the equation of the line that represents it in the table. So just remember, y equals mx plus b is the equation. We do not have the y-intercept. We do not have the slope either. But we can get the slope. We don't know how much he put into the box. So we can get the slope using the y2 minus y1 over x2 minus x1 formula. So I'm going to put x1, y1, x2, y2. Every time that you have a table like this, remember, number of tickets sold, the x is always on that left side, and the dollars is always the y, so we're just going to put the y there. So let's go ahead and we're going to show our work here. We're going to put the m equals y2 minus y1 over x2 minus x1. So 146, let me put this a little bit bigger because the numbers are not like numbers that are like 5 and 6, like whole numbers and stuff like that. This is like we're talking about money. So we're going to have 146.25 minus 108.75 over 13 minus 7. So I'm just going to go ahead and grab my wrong calculator. I'm going to go ahead and grab my calculator, and I'm going to press clear, bring down the fraction symbol there, and I'm going to put 146.25 in minus 108.75, and then divide that by 13 minus 7, and let's see what this comes out to be. Oh, nice, 625. M equals 625. Let the calculator do your work. So the equation now, but we're still missing the b. So we don't know what the b is, but if we had an x of 0, we would be able to tell what that other number would be. What that y-intercept would be. We don't have it. So what we're going to do is we're just going to go and use the point slope formula. Y minus y1 equals m times x minus x1. We have a point. We have more than one point. We have a point and the slope. So since we have the slope and a point, we're going to use the y1 that I labeled as 108.75 equals, the m is 625 times x minus x1. X1 is 7. So let's go ahead and do some math here. We're going to do distributive property. And we're going to have y minus 108.75 equals 625x. And then we're going to take this right here and put 625 times -7. All right. And don't forget about that -7. It's 43. I didn't even see it before it went away. 70.75. Move this down. I'm going to solve for y, 108.75 plus 108.75. And I'm going to cancel out this part of it, and I'm going to put y equals, almost at my equation, 625x. That's my slope. And this will be my y-intercept. I'm going to bring it up, and I'm going to do plus 108.75. 65. So here's my equation, y equals, and you have to put that y equals down to get full credit, because an equation is not an equation without an equal sign. And that is the equation. So part B, looking at your equation, how much money was initially in the box before selling any tickets? It was $65. Was in the box before selling any tickets. And that's it. All right. Could have wrote that on the line, but I guess not. So last topic. This is the last topic. Scatter plots. The owner of a coffee shop compared the amount of hot coffee in fluid ounces sold and the daily high temperature and had data shown in the scatter plot. Draw a line of best fit. Remember, a line of best fit is a line that goes through the center of all the points. Make it start at the y-intercept, the y-axis, and call it your, just go through the center of all the points just as best as you possibly can. That is just a little bit above 800 on mine. So I actually could move it up just a little bit, like right about there and right here. That goes through the center of all the points. And I'm going to call that 850 as, like, say that's my B right there, my y-intercept. That would be around B. And that goes through the center of all the points as best as I possibly can. So I'm going to put an arrow over here. And now I'm going to answer these questions. So I did the line of best, I drew the line of best fit. How many fluid ounces would the coffee shop sell if the temperature is 90 degrees? So I'm going to go to 90 and I'm going to go up to my trend line and I'm going to hit it there. And then I'm going to go over to right about there. So I'm going to say that they would sell about 325 fluid ounces. How many fluid ounces would the coffee shop sell if the temperature was 40 degrees? Let's go ahead and bring it up from 40. A little bit more because the temperature is, it's colder out. So it's a little bit above 600 And I'm going to say 625. All right, so let's go down. How many fluid ounces would the coffee shop sell if the temperature was 0 degrees? 0 degrees right here. They're really asking for what the Y-intercept would be there. So it's that starting rate at 0 degrees Fahrenheit. Mine would be like around 850, 840. I'm going to say it's 840. All righty. So let's go down to 2 right here. Which line represents the best fit for the scatter plot? Practice. Draw the trend line. So I'm going to draw a trend line. I'm going to move up here and I'm going to draw it through the center of all the points like that as best as I possibly can. And I'm going to put an arrow at the end right here. All right. Does the scatter plot have a positive or negative association? That is going up from left to right, so it is a positive association. Is the data on the scatter plot represent a linear or nonlinear function? It is a linear function. The reason why it's linear, like a scatter plot could really never be like, you're saying this, like points all over the place. I don't understand how it's linear. If it curves, if the points curve all at once, that would be nonlinear. If you can't draw a straight line as a trend line, it curves, you'll see it. It's a nonlinear scatter plot. This is linear. Does the data on the scatter plot have an outlier? No. Draw an outlier. I'm going to draw my outlier right here and circle it. So I'm going to circle it. So there's a question that we usually ask. What the outlier, what exam score does that outlier represent? Exam score right here would be here, and it wouldn't be 1, it would be 20, right? So like if that would be like a question, you would have to see what the y-axis would have and where the outlier is. The outlier is a point that is really far away from the rest of the data, and you kind of ignore it when drawing that trend line. Okay, so which association correlation best describes the data? I am going to draw and practice drawing the trend line. So that trend line would be going down. So it is a negative. Association. And you could say correlation is the same thing. Does it have an outlier? No, it does not. So we're going to draw this one also. And that is a positive association, obviously. Correlation means the same thing. Does it have an outlier? No, it doesn't. I'm going to draw this one right here. Doesn't have an outlier, so that's a positive trend. I'm getting positive association. Does it have an outlier? Yes, it does. That is it, and let's move on. Identify the correlation, which is association, correlation, for each of the scatter plots below. This has none. It is straight across. If you would say that this is a zero slope, so they're not going to ask you something like that. But if you ever asked about a line that is like that, what's the slope of that line? It's not positive association. It's not negative association. The next one is scattered all over the place. You cannot draw a trend line. Put no association for that. For this one going down right now, you have a negative linear strong association. So let me just go over what that means. Negative means it goes down from left to right, and obviously you can see my trend line is going down. Linear, it means that it is basically straight. It is basically straight. Strong means that the points are clustered close to the trend line. They're not really far apart. So we're going to do the same thing here. So that is a positive association, and it is linear. Positive linear. And we're going to call this a weak association. The reason why we're saying it's weak is because you see how like the points are a little bit further away from the trend line? That's what a weak association looks like. And just to finish things up, we are going to go on to number 5 right now. Which point in the scatter plot appears to be an outlier? Let me view this out and put this completely as a page width. So here's the outlier. It's far across from like the rest of the data. So it's in the 18th week, if you could see that number. So I'm going to go up, draw a dotted line. It is the 18th week paycheck at around 165. And I'm going to go right about there. It would be 18th week. It's not the 16th week. 16 would be here. That's out. First week is all the way over here. Obviously, that's not the outlier. The 4th week paycheck would be over here. That's not the outlier. D would be your answer, and that is it. Thank you for watching. I hope it helped. See you next time.